What is a calorimeter? A calorimeter is a device used to measure the amount of heat involved in a chemical reaction or physical changes. It helps determine heat transfer by monitoring temperature changes in a well-insulated environment.
An insulator container is a container of a calorimeter is insulated to prevent heat loss to the surroundings. This ensures that all the heat involved in the reaction is either absorbed or released by the materials inside the calorimeter.
Measuring heat transfer. So in a calorimeter, we measure the heat transfer by placing a sample in the water. When a hot object, like a metal, is placed inside, the heat flows into the water until they reach the same temperature. By measuring the temperature change, you can calculate the heat exchange using the formula.
This is the spirit candle below the calorimeter. The spirit candle or fire in a calorimeter provides the best source needed to raise the temperature of the substance being measured, allowing for the calculation of the energy released or absorbed.
This is the insulator container at the top of the calorimeter. It is to prevent heat loss, ensuring accurate energy measurements.
The thermometer, which is to measure the temperature change of the substance. It is very essential for calculating the amount of heat absorbed or released during the experiment.
The pump in a calorimeter calculates water or fluid, ensuring even heat distribution inside, while the other end helps regulate or maintain pressure and airflow.
And finally, we have the beaker. The beaker is to source sample.
Our calorimeter is a big factory that is being controlled by people inside the office. We have a long tube connected to the office to transfer information and data from the calorimeter.
In the office, got tables, chairs, and computer for the workers, and the boxes is to store items from the calorimeter.
Now let's talk about how we calculate the heat absorbed or released using a calorimeter. The formula we use is Q equals to MC triangle T, whereas Q stands for the heat energy measured in joules, M is the mass of the substances we're measuring, typically in grams. C represents the specific heat capacity of the substances, which is a constant value. It tells us how much heat is needed to raise the temperature of 1 gram of the substances by 1 degree Celsius. Triangle T is the temperature change, or the difference between the final and initial temperatures of the substances. So let's break it down. It has been found that 4.2 kilojoules of energy raises the temperature of 1000 grams of water by 1 degree Celsius. If the volume of the water in the calorimeter is 500 grams, 2.1 kilojoule will raise the temperature by 1 degree Celsius. The amount of energy released by the field is found by multiplying the rise in the temperature by 2.1.
First, we use the thermometer to measure the starting temperature of the substance. Then, after heating it with the spirit candle or another heat source, we measure the final temperature. The difference between these two is triangle T. Next, we weigh the substance to get its mass, M, and find its specific heat capacity, C, from a reference table for that material. Once we have all these values, we multiply them together. That gives us the total heat energy, Q, that the substance absorbed or released during the experiment. By using this formula, we can accurately calculate the heat transfer and better understand how much energy is involved in different reactions or processes.